terminal A and terminal B and terminal C. Now we already derived the equations from delta to star. As it is an interconversion, here we can use the formulas of delta to star. Both are because interconversion. Delta to star formulas. So delta to star means if the R1, R2, R3 are given, unknown values are, this is, let us say this is RA, RB, and this is RC, RA, RB, RC. Okay. Now we have the formulas for this delta to star. What are the formulas here? Once if you know R1, R2, R3, I think this is R2, I think so. R2, this is R3. Then what will be the RA? Yesterday, in the previous class, we derived RA equal to R1, R3. Because if you draw a star inside the delta, so R1, R3 by R1 plus R2 plus R3. So similarly, RB equal to, so RB comes here, and the formula will be R1 into R2. R1 into R2. R1 into R2 by R1 plus R2 plus R3. Next, what will be the RC, Amma? R2 R3 by R2 R3 by R1 plus R2 plus R3. Here I am taking these formulas to derive the expressions, or to find the what is the R1 value, R2 value, and R3 value. And here known values are RA, RB, RC are the known values. Unknown values are R1, R2, R3. For getting those values here, what I am doing is that I am multiplying equation 1 and 2. Equation 1 and 2. What is the equation 1 into 2? Multiplying 1 into 2. So if you multiply LH side, that will be RA into RB, which is equal to this one into this one. That means R1 R3 by R1 plus R2 plus R3 into R1 R2 by R1 plus R2 plus R3. 1 into 2, which is equal to R1 into R1, R1 square into R2 R3. The derivation is important, is all of you follow. R1 plus R2 plus R3 whole square, which is equal to RA into RB. So let us say this is equation number 4. Similarly, let us multiply equation 2 and 3 and 3 and 1. Okay. Let me take another slide here. So 2 into 3, multiplication of 2 into 3 becomes 2 into RB kada, RB, 3 into RC. So which is equal to, I'm going to write directly here. So in the both the terms R2 is there. So we can write R2 square into R1 R3 by R1 plus R2 plus R3 whole square in the denominator. Likewise, 3 is multiplied with the 1. Then that will be RA, that will be RA into RC, which is equal to R3 square into R1 R2 divided by R1 plus R2 plus R3 whole square. So this is, let us say, equation 4 and equation 5. Now, after getting 3, no. This is equation 5 and this is equation number 6. Now we have the equations 4, 5 and 6. Now I am going to add these equations, 4 plus 5 plus 6. So what is the fourth equation here? RA into RB. So let me write the fourth equation here, please. Here is this. Let me add the fourth equation. The fourth equation will be RA RB, which is equal to R1 square R2 R3 by R1 plus R2 plus R3. This is equation number 4. Now add all the equations here. We add all the equations. What are the LH side terms? Yeah, RB plus RC plus RA, no, RC and RC, which is equal to take RH sum, which is equal to R2 square into R1 R3 divided by R1 plus R2 plus R3 whole square plus. Are you getting or not? Please respond, Amma.
Yes, sir.
Yeah. This derivation is important. That is the reason why each and every step I am writing here. And one more thing, I posted the unit 1 notes. Did you see that? At 4:30, I think so. I posted the unit 1 notes. In that notes, all the things will be there.
Yes,
so
sir.
go through that notes, Amma. Next one is this is I add all the terms here. So R2 square R1 R3, R3 square into R1 R2 divided by R1 plus R2 plus R3 whole square plus R1 square into R2 R3 by R1 plus R2 plus R3 whole square. Now here, let us take the LCM. LCM is R1 plus R2 plus R3 whole square. And let me continue on the slide here. So finally, if you take RA, RB plus RB, RC plus RA, RC, which is equal to, the LCM will be R1 plus R2 plus R3 whole square. Then in numerator we have R1 square into R2 R3 plus R2 square into R1 R3 plus R3 square into R1 R2. Now in numerator what I am doing is that I am taking the common of R1 R2 R3. R1 R2 R3. If I take R1 R2 R3 common in the first term, what is the term which is left in the first one?
R1.
R1, very good. In the next term, R1, R2, R3, so R2. Like that, in this we have R3 divided by R1 plus R2 plus R3 whole square. Now we can cancel out this one, R1, R2, R3 and square. So finally what we will get here, R1, R2, R3 by R1 plus R2 plus R3. So which is RA, RB plus RB, RC plus RA, RC. Let us say this is equation number 7. Now, after getting the equation 7 and divide the equation 7 with the equation 3. Equation 3 is the RC equation. So in the next slide, let us remember the 7th equation. I'm doing 7 by 3, Amma. 7 equation is just the previous one. What is the 7 equation? Equation number 7 is RA, RB plus RB RC plus RA RC, which is equal to R1 R2 R3 by R1 plus R2 plus R3. So now what is the third equation? RC equal to R2 R3 R3 by R1 plus R2 plus R3 amma. Now divide. So divide these equations. So this LH side terms by RC, and here this term by this term. Now divide these values here, which implies RA RB by RC, RA RB by RC plus RB RC by RC. So RC and RC will get cancelled out in the second term. Then we have RB. Next RA RC. Here also RC cancel out. Then we have a RA. Now come to this RH side. In numerator, R2 R3 will get cancelled out. So R1 remains in numerator. And what about the denominator? R1 plus R2 plus R3 here. Here R1 plus R2 plus R3. So total denominator value will get cancelled out. So finally, if you observe this equation, then we have R1 equal to RA plus RB plus RA RB by RC. So this is the equation number 8. Now we got R1 value, which is the value of delta from star. Known values are RA, RB, RC are the known values. Unknown value is R1. Okay, na? So this is R1. Likewise, you have to calculate R2 and R3 also. So to calculate R2 and R3, you have to divide 7 equation by equation 1. Okay. Up to this, is it clear, Amma? So far, anybody have any doubts, you can ask. Okay. Now, let us do 7 by 1, equation 7 by 1, which implies 7th equation is RA RB plus RB RC plus RC RA, which is equal to R1 R2 R3 divided by R1 plus R2 plus R3. Now equation 1 is RA. So RA, which is equal to R1 R3 by R1 plus R2 plus R3. Now divide these equations here. Yeah. See here in this RA RB by RA. So RA will get cancelled out. Then we have RB plus RB RC by RA. RB RC by RA plus RC RA by RA. RA will get cancelled out. We have only RC, which is equal to, now if you come to the numerator RH side, R1 cancelled out, R3 we left with the R2, and denominator R1 plus R2 plus R3 and R1 plus R2 plus R3 will get cancelled out. So finally we got R2. So then R2 equal to RB plus RC plus RB RC by RA. This is equation number 9. Now we got R1 R2, and to get the R3 we have to divide equation 7 with the equation 2. Equation 7 by equation 2. What is the equation 7 here? 7 is again RA RB plus RB RC plus RC RA, which is equal to R1 R2 R3 by R1 plus R2 plus R3 divided by 2. What is the 2 equation? RB, which is divided with the R1 R2 by R1 plus R2 plus R3. So let me cancel out the remaining things here. RA RB by RB. RB will get cancelled out. We have RA plus RB RC by RB. So we left with the RC here. Next, RC RA RB. So there are no cancelled terms here. RA RC by RB. So which is equal to R1 cancelled out, R2 cancelled out. We have R3. Denominator, these two terms will get cancelled out. Now we have R3. So finally we got the R3 equation also. R3 equal to RA plus RC plus RA RC by RB. Okay, this is equation number 8, 9, 10. Okay, so sorry. R3. So this is equation number 10. Once if we get all the equations, let me write all the equations in a new slide. Now we have this is RA, RB, RC. These are the known values, terminal A, terminal B, and terminal C. What are the unknown values? We are going to convert it into delta. So A, B, and C. We have R1, R2, and R3 here. So now let me write the formulas for R1 here. R1, these are the unknown values. R1 equal to RA plus RB, RA plus RB plus RA by RC. That is R1. What about the R2 here? So R2 equal to RC plus RB into RC by RA. Okay. Now finally R3. What is the R3 here? RC plus RA, RC plus RC by RB. So these are the formulas. All of you note down these formulas, please. I will give 2 minutes of time. Anyway, derivation will be in the material. Please note down the formulas. Star to delta formulas. Star to delta conversion formula. Please, all of you note down. I will give 2 minutes of time. Please note down this formula. Completed?
Yes, sir.
Yeah. Now let us see how to remember these formulas without by hearting. Let me give a thumb rule to remember these formulas here. See, this is a star, right? So if you want going to convert it to delta, let us draw the delta connected fashion resistors. This resistance will be R1. This is R2 and this is R3. Now, while writing the R1 formula, for R1, what are the adjacent resistors? Please tell me. R1 ki adjacent resistors ఏమేమి ఉన్నాయమ్మా? One is RA,
RA, RB.
RB. So add these RA and RB here. RA plus RB, sum of the adjacent resistors, plus product of these adjacent resistors, RA, RB, divided by what is the other resistance here? RC, divided by RC. Automatically RA, RB వచ్చిందంటే RC ఉంటుందమ్మా. Likewise, R2 తీసుకోండి. If you want to write R2 here, R2. What are the adjacent resistors here? One is RC and another one is RB. So RB plus RC plus RB RC into RB RC by what is the remaining? BC undi. Inka what is missing here?
RA.
RA. That means other resistance. Likewise, you have to remember these formulas. R3 and R3 adjacent resistors are RA and RC. So RA plus RC plus product of these by opposite resistance or other resistance. Other resistance is RB. So how to remember here? Sum of adjacent resistors plus product of adjacent by opposite resistance, remaining resistance or other resistance. So ఇలా గుర్తుపెట్టుకోండి, మీకు ఈజీగా ఉంటుంది వితౌట్ బై హార్టింగ్. Okay. Now, after having this, so in the circuits, the star may not be look like this, and this delta may not be look like this. It may be considered as a pi, and it may be considered as a t. So for sake of understanding, I will give a clarity for this. So suppose if there is a delta inverted కూడా ఉండొచ్చు అమ్మా, ఇలా కూడా ఉండొచ్చు delta. Suppose it is a delta. In the circuit, the delta may be given like this. ఇది కూడా డెల్టా కిందకే వస్తుందమ్మా. అంటే ఈ R1, R2, R3 ఉంటే ఇక్కడ R1, R2, R3. సో బోత్ ఆర్ సేమ్ డెల్టా కనెక్టెడ్. ఇక్కడ కామన్ నోడ్, ఇక్కడ మధ్యలో ఏం రెసిస్టెన్స్ లేదు కదా. సో ఇట్ ఈస్ కన్సిడర్ యాజ్ ఎ సింగిల్ నోడ్. ఇదంతా ఒకటే నోడ్. యూ మే డ్రా ఇన్ ఎనీ ఫ్యాషన్. సో దిస్ ఈజ్ ఆల్సో ఏ డెల్టా, అంటే పై నెట్వర్క్ అంటారు. ఇదేమో డెల్టా అండ్ పై నెట్వర్క్ బోత్ ఆర్ సేమ్. ఓకే, ఇలా కూడా డ్రా చేయొచ్చు అని చెప్తున్నాను. ఇంకొకటి స్టార్ కనెక్షన్ ఇలా కూడా ఉండొచ్చు అమ్మ మీకు. ఇప్పుడు నేను డ్రా చేసినట్లు కాకుండా ఇలా కూడా ఉండొచ్చు. And this may be similar to, you can draw any way. That means the circuit may be look like this. This is RA, RB, RC. Don't confuse here. If the circuit is given like this, don't confuse. This is a star fashion only. RA, RB and RC. Both are similar, amma. Don't confuse here. And the circuit may be here. Let me draw another one. ఇలా కూడా ఉండొచ్చు. All these come under what? Star connection. This will be a delta. Okay, no? So in circuits, they may give like this, it will be considered as a delta. Right? Let us do some problems on this. So wait for a minute. I'm opening this material. So this is the material I shared with you in the Google Classroom. Take this problem, all of you. Transform the Y or star. Transform Y network in the figure to a delta network. See here, ఇది డ్రా చేసుకోకండి, ఇది డ్రా చేయకండి, ఇది డ్రా చేయకండి, ఫస్ట్ ఇది నోట్ చేసుకోండి. దిస్ 10 ohm and this is 20 ohm and this is 40 ohm. ఇది ఒకటే తీసుకోండి. అంటే మీరు ఎలా డ్రా చేస్తారంటే draw like this. This is 10 ohm, this is 20 ohm and this is 40 ohm. This is terminal A, B and C. This is T network. T network is same as star connected network. Is the screen visible, Amma? Please respond. Understand?
Yes, sir.
Okay. Now let us solve this problem here. This is the star connected resistor. 10, 20, 40. So let us take in ఇక్కడ మీకు చేయడానికి కొంచెం కన్ఫ్యూజింగ్గా ఉంటుంది బికాజ్ ఆల్రెడీ సొల్యూషన్ కూడా ఉంటుంది. సరే, లెట్ us do this problem here only. Now let me draw the delta here. డెల్టా ఎట్లా కన్వర్ట్ చేస్తారు? ఇట్లా. ఇది మీరు పెన్సిల్తో డ్రా చేసుకోండి. పెన్సిల్ డ్రా చేసుకుంటే మీకు ఈజీగా ఉంటుంది. తర్వాత అరైవ్ చేసుకోండి. R1, R2, R3 అనుకోండి. Now I am going to calculate R1 value. R1 value అంటే ఏంటి? డోంట్ బై హార్ట్ ది ఫార్ములాస్. ఇప్పుడు చెప్పాను కదా, సమ్ ఆఫ్ adjacent side resistors. Sum of adjacent for R1, what are the adjacent resistors? 10 and 20. So 10 plus 20 plus product of adjacent sides. Already formula కూడా రాసింది. Product of adjacent sides అంటే 10 into 20 by what is the other resistance here? Opposite side resistance is how much? 40 ohms. So which is equal to, this is 30 plus 10 fours, 10 fours are 40, 4 5s 35 ohms. So this will be 35 ohms. So likewise calculate R2. Here if you want to calculate R2, for R2 adjacent resistors are 20 and 40. So 20 plus 40, 60 plus 20 into 40 ఎంత వస్తుందమ్మా 800 80 800 divided by what is other resistance 10 cancelled out, so 140 80 plus 60 140. Likewise calculate R3 and tell me the R3 value. Solution already undi ikkada
70 sir.
Yeah, 70. Let us see any problem is there for delta. The material already share చేశానమ్మా మీకు 4:30 కి అట్లా. ప్లీజ్ గో త్రూ ద మెటీరియల్ అండ్ డెరివేషన్ కూడా దీంట్లో ఉంది, ఒకసారి చూడండి. ఏమన్నా డౌట్స్ ఉన్నా కానీ అడగండి. డెల్టా ప్రాబ్లం, స్టార్ ప్రాబ్లం. ఇక్కడ ఒక ప్రాబ్లం ఉంది చూడండి. Let us take the problem number 6. Obtain the equivalent resistance RAB in each case. First ఈ ప్రాబ్లం నోట్ చేసుకోండి. ఇక్కడ సొల్యూషన్ లేదు. Let us do the solution here. But answer is there. 140 ఉంది. చూద్దాం. Let us see this one. So all of you note down this problem. First problem. Twenty, 30, 40. Ohm, 10, 60, 50. 10 ohm, 50 ohm, 50 ohm. Last one is 80. Yeah. So let us see the solution here. And stop sharing this and let us open Canvas app, whiteboard. Yeah, now see here. Are you able to see this problem? We are going to calculate RAB. కనిపిస్తుందమ్మా ఇక్కడ?
Yes sir.
And now here see, you can solve in two ways. One delta to star చేయొచ్చు, star to delta చేయొచ్చు. బట్ మనము స్టార్గా తీసుకున్నాము. We can take 30, 40, 10 as one star. Otherwise 60, 50, 10 as another star. Okay, because we can't say this is series and 40, 10 తీసుకుంటే ఇది సిరీస్ ఆ ప్యారలల్ అని చెప్పలేము మనం. అందుకని మనం స్టార్ టు డెల్టా కన్వర్షన్ ఇచ్చేస్తాము. సో what I am doing is that I am taking this 10, 40, sorry, this 30, 40, 10 as a star. Let us calculate delta connected resistor, delta connected value. ఇది మీరు పెన్సిల్తో డ్రా చేసుకుంటే బెటర్, ఎందుకంటే తర్వాత మీరు అరేంజ్ చేసుకోవడానికి కూడా ఉంటుంది. సో లెట్ us take this is R1 అనుకోండి, ఇది R2 అనుకోండి. ఇది R3 అనుకోండి. Later we can erase this star. Now let us calculate R1 resistance. R1 resistance calculate చేస్తున్నాం చూడండి. R1 equal to adjacent resistance are 30 and 40. But actually in the examination you have to write the formulas. Formulas could write better. 30 plus 40. 30 into 40 by what is the opposite resistance? 10. ఎంత వస్తుందమ్మా? 70 plus 4 3 120. సో టోటల్ వాల్యూ ఎంత వస్తుంది?
1320 sir.
ఎంతమ్మా? 190యా? అంతే కదా?
Yes sir, 190.
Yeah.
190 sir.
Next, likewise calculate R2. R2 equal to R2 కి adjacent ఏంటి? 10 plus 40 plus 400 by 30. సో క్యాలిక్యులేటర్స్ రెడీగా పెట్టుకోండి. 400 by 30 అంటే ఎంత వస్తుంది? 400 by 30 13.33 plus 50 అంటే
63.33
ohms. Next, R3 equal to, this is R3, adjacent resistors are 30 and 10. So 30 plus 10 plus 30 into 10, 300 by other resistance is 40. So which is equal to 40 plus 300 by 40. 300 by 40.
7.5.
7.5 అంటే 47.5 ohms. This is R3. Okay, now yeah, once if you get these values, you can remove this star connected resistors. ఇవన్నీ remove చేసి circuit redraw చేయండి. You redraw the circuit, how it will look like? So there is a 20 ohm, ఇక్కడ R1 ఉంటుందమ్మా. Next from here R3. Next ఇక్కడ ఎంత ఉంటుంది? R2. There is no rule to draw the circuit straight. You may bend the circuit like anything. This is 60 ohm. This is 50 ohm. This is no. We are the now what is this R1 value? R1 and this one. This is 190 and R2 is this, that is 63.33 ohms. And what is this? 47.5. Now we can say which is parallel or series. If you see here, yeah, this 60 and this 47. This is 60 and 47. These two are connected in parallel. Okay na? Next, you may draw at this point also అమ్మ 80 ఇక్కడ డ్రా చేస్తున్నాం కాబట్టి ఇదంతా ఒకటే నోడ్, ఇదంతా సేమ్ నోడ్, and you can say this 63 and 50 are connected in parallel. సో ఆ ప్యారలల్ రిజల్ట్ ఏంటంటే చెప్పండి. సర్క్యూట్ ఎలాగో డ్రా చేయొచ్చు, డోంట్ కన్ఫ్యూజ్ హియర్. సి దిస్ ఇస్ 20, ఇది 80 ఓం రెసిస్టర్. చెప్తారమ్మా, ఈ ప్యారలల్ కాంబినేషన్ ఎంత వచ్చిందో చెప్తారా?
26.51 సార్.
ఇది 26.51, ఇక్కడ R1 ఉంటుంది, 190 ఉంది. నెక్స్ట్ ఈ రెసిస్టెన్స్ ఎంతమ్మా?
27.94.
27.94, ఇక్కడ 80 ఉంది. Now see how these two resistors are connected. ఈ రెసిస్టర్స్ ఎలా కనెక్ట్ అయినవి? ఈ టూ రెసిస్టర్స్ ఎట్లా కనెక్ట్ అయినాయమ్మా? కాదు, ఇవి రెండు ఇక్కడ చూడటానికి ప్యారలలే, కానీ కరెంట్ ఎలా ఫ్లో అవుతుంది? సేమ్ కరెంట్ కదా. ఐ హోప్ యు ఆర్ గెటింగ్. సేమ్ కరెంట్ ఫ్లో అవుతుందా లేదా చూడండి ఒకసారి. ఇక్కడ కరెంట్ ఇక్కడ డివైడ్ అవుతుంది, ఇదంతా సేమ్ కరెంట్ ఫ్లో అవుతుంది కాబట్టి ఇదంతా సిరీస్ అవుతుంది. సో 26.51 ప్లస్ 27.94 చేయడం, ఈ రెండు సిరీస్, దీస్ టూ ఆర్ కనెక్టెడ్ ఇన్ సిరీస్. సేమ్ కరెంట్ ఫ్లో అవుతుందా లేదా అని చూడండి ఒకసారి. కొంచెం కన్ఫ్యూజింగ్గా ఉంటుంది, బట్ ట్రై టు అండర్స్టాండ్. సాయి కుమార్ చేస్తున్నారా బాబు?
Yes, sir.
Yeah. So this is 20 ohm and this is 190. And ఈ సిరీస్ ఎంత వస్తుందమ్మా? 26.51 ప్లస్ 27.94, రెండు యాడ్ చేసి చెప్పండి.
54.45.
0.45. Now let us see. Here the current is divided between these two resistors. Now how these two resistors are connected, 190 and 54? 190 ohm and 54. కరెంట్ డివిజన్ అవుతుంది కదమ్మా.
Parallel, sir.
ఈ ప్యారలల్ బ్రాంచ్ వేయండి. 194 into 54.45. 190 into 54.45 by 190 plus 54.45, which is equal to, let me calculate here, 190 into 54.45.
42.32.
42.32. Okay, na? Yeah, this becomes 42.32. Then the total circuit will be, this is 20 ohm, 42.32, this is 80 ohm. సో ఫైనల్గా ఈ టోటల్ కాంప్లెక్స్ సర్క్యూట్ని మనము సింపుల్ సర్క్యూట్గా రిడక్షన్ చేసాము. నౌ వీ కెన్ సే ఆల్ దీస్ రెసిస్టర్స్ ఆర్ కనెక్టెడ్ ఇన్ సిరీస్. అన్ని యాడ్ చేయండి. 20 plus 42.32 plus 80. RAB 20 plus 42.32 plus ఎంతమ్మా? 140.
2.32.
140 RAB equal to 142.32. Let us verify the answer here. 142.32. So, anybody have any doubts here? Please ask. అది రిడక్షన్ చేసేటప్పుడు అది మీ ఏమంటారు సిరీసా ప్యారలలా అనేది మీకు నెంబర్ ఆఫ్ ప్రాబ్లమ్స్ ప్రాక్టీస్ చేస్తే అర్థమవుతుంది. Let me check the answer once here. Yeah, we got exact answer. 142.32. So we got the same answer, means what are the things we have done are correct. Don't forget to write the ohms. Yeah. Next, let us take this problem. So try to solve this problem. Meanwhile, I will take the attendance here.